Hey guys, Ivana here. This is the third video of the APR section. Let me remind you that this is not all-inclusive, meaning that you all have to remember everything that you've learned throughout the year.
Okay, thank you very much. This is the final review series for the videos for the spring 2019 Math 3 final exam review. And like she said, it's not all-inclusive. Let's get right into it. This is the question you were asking. If you're using the remainder theorem. This is the remainder theorem. The previous one we did was factor theorem. This is the remainder theorem. If they're asking you to evaluate a polynomial at this value, they're saying, hey, use -2. You say, okay, I'm going to use -2. That's when we put -2 right into the window. Okay? So we're going to do the same thing, synthetic division again, 2, -3. Hey, is that in standard form? Can everybody help me out? Yes. Is it? Yes. Is it? Okay, I agree. Fine. Jeez, don't have to yell. Okay, you guys got your calculators ready? Okay, I'll start off the easy part. That's 2, -4, -7, 14. I'm already lost. 20. Wait, I can do this one. -40, -48. I can't do this one. Wait, I can. 96, 106. I can't do this one. Wait, yeah, I can. -212. So what's the remainder? -12. So apparently, if I plugged -2 into x and did all the exponents and did all the addition and subtraction, it would come out to be -12. And that's how you use the remainder theorem. Okay? Now, let's do this divide using an area model. This is gonna, when you guys look at the previous video and you see the long division, you're going to see just how similar this is. I guess I could have used the same polynomials, but I didn't, so sue me. Okay, so we're going to start off with x plus 2 on the side, and all you have to do is just draw your lines like this. You'll fill in the other lines in a minute. Okay, we know that our answer ends up with x to the 5th using the area model, so we're going to start with that x to the 5th. Here's the key to area model division. It's just divide, multiply, subtract, rinse, repeat. That's all it is. It's the same thing as long division. How many times is x going to x to the 5th? X to the 4th. Multiply x to the 4th times 2 plus 2x to the 4th, right? But now we need to subtract. What does our polynomial say we end up with inside the box? We end up with -8x to the 4th. So here's what you do. You start at -8 and you subtract that number. What's -8 minus 2? -10 x to the 4th. Think about that, boys and girls. On this diagonal, -10 plus 2 equals -8. That's how you make sure you're ending up with what the polynomial is. Rinse and repeat. X goes into this one. Let's see, -10x cubed. Multiply that times this. I have no idea what this answer is. I made this one up. So this is -20x cubed, right? Okay. What are we supposed to end up with for the x cubed? We're supposed to end up at plus 12, right? So start at 12 and subtract a -20. What is happening when you subtract a negative? You're adding. So that's going to be 32x cubed. Let's check and make sure. 32 minus 20 is 12. Got it. Rinse and repeat. X goes into this, plus 32x squared. Holy crikey, this is a big problem. Multiplied 64. Where are we supposed to end up for the x squared? We're supposed to end up at -1. So start at -1, subtract 64. So what do you get? -63. X squared. Nope. -65. No. It's -65. Start at -1 and subtract 64. -65. Jeesh. So -65x times 2 is -130x. Where are we supposed to end up with the x's? At 9. 9 plus 130 is plus 139x. And that's plus 139 times 2. What is that? 278. We're supposed to end up there. We're supposed to end up at -13. -13 minus 278 is minus 291. Yes.
How is 278
139 times 2 is 278.
Oh.
Right? Isn't it? Okay, so x doesn't go into 291, so that's your remainder over x plus 2. Yeek, I don't know. Which do you prefer? Long division or long with an area model or the regular long division? The answer should be neither. Let a computer do it for us. Okay?
On your test, are you going to make it like if the direction says the line using the specific method you have to?
Well, the thing is, we talked about this last semester, so you probably don't remember. If the divisor is linear with a constant of 1, then it's much easier to do synthetic. But if it's not, if this is like 3x plus 5 or God forbid, let's say your divisor was x squared minus x plus 3. Your only choice would be to do area model, and you would have 3 rows right here. And it would get really ugly and complicated quick. Okay? All right, that's it for that one.